This conference will now be recorded.
Welcome to all participants in third session of sixth day of this FDP program. We have great pleasure to welcome such a knowledgeable professor and a very dynamic personality with us, Dr. Masood Siddiqui. He is a professor in the area of decision science, business analysis, and Dean Research at Jaipuria Institute of Management, Lucknow. He has PhD in mathematics, statistics, and was CSIR fellow in mathematical science. His area of expertise in business analytics, multivariate data analysis, decision modeling, soft operation research. He has wide experience of consultancy and also has taken more than 100 FDPs in various areas. He has co-authored famous book, The Statistics of Management by the Pearson publication. He has more than 40 research papers to his credit in various international journals and has more than 400 Google Scholar citations. Now this is the brief CV of Professor Siddiqui. Due to shortage of time, I cannot read his full profile. So sir, really I
Thank you.
and
Thank
with
you.
our organizing team very grateful to welcome you and request to deliver your lecture. Please sir, Siddiqui sir, please over to you.
Okay. Thank you, Dr. Kranti, and thank you, organizers, for giving me chance to interact with the participant. The topic that is assigned to me is data analysis using SPSS. As you know, the full form of SPSS is statistical package for social sciences. So this software has primarily been made for the social scientists. So it is much user friendly and doesn't involve much of the expertise as far as computers are concerned. So the most important thing is to have the knowledge what is to be done, and after that only we come to how it is to be done. So the first point is, uh, I will start from very basic, how the data will be fed to SPSS. There have been two methods of feeding data. One is we can directly feed uh, uh, the data in the SPSS file, and the other method is we can make Excel file, and that Excel file will be exported to SPSS. So obviously everyone is much familiar with Excel, and Excel is available everywhere also, right, in all the computers. So I am taking this method, and then I will explain the uh, the future part. Suppose this is an Excel file. This is an Excel file that is an academic performance file. It has these following variables. These are the variables. The first is the roll number. Second is the gender. The next one is class 10 performance, that is in the percentage. Class 12 performance. Next is the graduation performance. And next comes the subject taken in the graduation. And finally the CAT percentile. So this is the data from around 50 students. That data has been collected. As you see, all the variables are in the column as the rule is, and all the cases, all the respondents are in the rows. The most important thing is, when you want to export an Excel file into SPSS, the variables should only be in the first row, right? As you see, all the variables are in the first row only. So these are the variables. So this is the file, and this file will be exported to SPSS. So hope the participants are familiar, get familiar with this file. So this is the file, and we have observation for 50 students. So this is the last case, and it is starts from the roll number 1 and goes to roll number 15. And these are the variables. These are the data that can be entered. So in order to convert this file into SPSS, the first thing is we have to close, because as you know, a file will be exported from one place to the other place only if it has been closed. So I am closing this file, and this file will be shared with uh, SPSS. So I am closing this file and sharing another file. Okay. And now, as you see, this is the this is the SPSS format. SPSS has two windows. One is data view and other is variable view. Data view has exactly the same format just like the Excel. Here in the column we have variables, and in the rows we have cases or the data. And the variables view are and this part of or this pen is used in order to define the variables. As you can read, this is the name of the variable, type, width, decimal, and this will be we will discuss later on. So this is our SPSS file and SPSS data file, and through this file we want to convert an Excel file into SPSS file. So just like an Excel, we will open um, our desired file. So we will go to file, then we go to open, and since we are importing the data, so we will click data. Again we will go to the file, then we will go to open. Since file is already constructed, then we press OK, data. So in the data we give the path. Suppose this file is located in the desktop and in the folder named as NSCB, right? So by default, the file that are shown are having SPSS link, right? This is the SPSS file. But we want to convert an Excel file or XLS file, so we change the file format to Excel or XLS. Now this file is open. This is our file. This is the case academic performance data. So this is the file, right? And we will press OK. As you read, this is the opening Excel data source. It is the path where the file has been situated. The most important thing is that I have already mentioned that only the first row are used for the variable. So by default option is variable, read variables name from the first row. You can convert the sheet number 1, right? Here we have only sheet number 1, so you can convert the sheet number 1. And suppose you don't want to convert the entire file, you will have the range. So suppose we want to convert the entire file, then we press OK, right? So now you see, this is that was the Excel file with these headings has been converted to the SPSS file. The first variable is roll number, the second is gender, next is class 10th, class 12th score, graduation score, graduation streams, and the third one is the CAT percentile. So this is the SPSS file that has been constructed using Excel. Now, as I mentioned, in Excel, we don't define the variables. In SPSS, there is options of defining the variables. So these are the variables. These are the uh, variables, and these are the type. All the data has been numeric. Numeric means everything has been entered in the numbers form. This data has been numeric. Right? Now the first thing is we can define since we have used code number 1 for male and code number 2 for female, so we can define these codes also. These codes will be defined using the column values. So this is the values, and suppose we want to define the gender values, so we will go to the uh, cell of gender and the value, and we go to the extreme right, and when we press, so there will be a button. So as we press, this value label dialog box is open. This is known as dialog box because through this box we make a dialog with SPSS. So now we can define the values for the gender. Since 1 is used to define male, so 1 is for male and 2 for females.
Sorry to interrupt you, sir, but
Yes,
your screen is showing nil, sir.
okay.
Yes.
Now is it visible?
Yes, sir. Yes, sir. It's visible now.
So I am explaining that again. Suppose we want to define the values of gender, right? So for gender, we have taken code 1 for male and code 2 for female. And since we want to define, we want to explain to SPSS that 1 means male and 2 means female. So we will define the values. For that, we will go to the value column, and on the value column, we will go to extreme right in the cell, and we will press this button. When we press this button, then this is the dialog box. This is known as dialog box because through this box we make a dialog with SPSS. Now we can define the values, 1 as male and 2 as female, and they has been added. As you see, male and female are in parentheses, right? So it means whatever you write will be displayed exactly in the similar manner in SPSS also. If you write M, then the output will display M. If you write F, then the output will display F. Exactly this format will be displayed, and we press OK. So we have defined 1 as male and 2 as female. Now there is one more categorical variable, that is the graduation stream. We have 4 graduation stream. Now these graduation stream will be explained, right? So these graduation streams are, suppose 1 for professional, means a student has taken any professional course in the graduation. 2 for commerce, 3 for science, and 4 for arts. These are the 4 streams that have been defined, right? So we will press OK, and now everything has been defined. Suppose we want to check what course has been taken, you can press this button, right? When you press the button, you will get the exact value. किसी का ऑडियो ऑन है, अगर वो ऑफ कर ले तो देयर वोंट बी एनी डिफरेंस.
Participants, please mute your audios. Participants, please mute your audio to avoid any kind of disturbance.
Okay, right?
Yes.
Now when we go to data file, so this is the file which is in the numeric format, and suppose we want to see the coded thing, means we want to see the categorical variables, means we have defined gender and we have defined graduation stream. So this is the button that is used to convert code to its description, means value label button is there, right? This is the button. When you press, you will have, means the first respondent is a male with the percentage of 64 in class 10, 72 in class 12, 59% in graduation, and science in the graduation stream. So by this manner we can convert an Excel file into an SPSS file, and when we convert this file, so this file can be saved just like we do for all our SPSS purpose. So hope the converting Excel file into a SPSS file is clear to all the participants. Is it clear? Okay. Now, I will consider another case, then we will discuss that case, right? So this case is used just to define how an Excel file can be converted to an Spss file. Now I am sharing a case that we will be done. So this is a case. So I request the participant to read this case and then we move forward. This is the case. The important thing is this case is written for a company that is Ventura. It has 1150 outlets or sales executives, right? But the information or the data that has been collected is from a sample of 60 executives. So we have data from 60 sales executives, right? This information is collected on the following variables. The first one is the location, second one is the type. Location means which region the executive or the outlet belongs. The second is the type of the outlet, whether that outlet or that executive belongs to a rural outlet or an urban outlet. And these are the four sales figure of different quarters, right? So this is the case that we are taking up. So hope you are familiar with the cases. Now we will develop, we will use a SPSS sheet related to this case, that is the Ventura sales. So I am sharing the data now. Okay, so now this is the data file that we are using, right? So just to recollect what are the variables of this case. So the first one is the outlet number, that is not much of importance. The second is the location. It has four locations: northern, eastern, western, and southern. After that, we have type. Type is there are two type of outlets or the executives. One is the urban outlet and two is the rural outlet. And these are the sales of the four quarters: Q1, Q2, Q3, Q4. So as you observe these variables, these are the six variables. Of these six, everything is in the numeric form. As you see, everything is in the numeric form. So for any analysis, only numeric form can be used uh, for the analysis purpose in SPSS. But among these numeric variables, we have two variables: location and type. They are not actually quantitative variables, they are non-metric variables. Non-metric variables means these variables uh, are categorical in nature and they are not measured. The first is the location, one, and the type. So as you know, the nominal scale or the categorical scale has been used to define location and type, and rest four are the and quantitative variables. They are in the metric form, right? So we have variable Q1 cell, Q2 cell, Q3 cell, Q4 cell as metric variables, and location and type as non-metric variables. Okay, so now whenever we start the analysis, so what should be the first thing? As you know, whenever you meet a person, right? So whenever we meet any person for the first time, we try to screen that person. Means we try to observe that person, how that person is. If that person appears to be friendly, that person appears to be acceptable, then we shake hand or we introduce ourselves or ask for his or her introduction. But if that person doesn't look approachable or doesn't look proper, we don't move forward. So this concept is known as screening. The objective of the screening is to know the is to just to guess about the characteristics of the other person, right? So in the same manner, whenever a data is available to us, we try to know about the basic characteristics of the data. So we try to screen the data to know what are the basic characteristics of the data. This concept is known as exploratory data analysis. So first thing is exploratory data analysis. The objective of the exploratory data analysis is number one, to screen the data. What are the basic characteristics of the data? The second is also to know what are the characteristics of the data, or the data is of good quality or not. As you observe that these are the sales figure, as you observe, suppose in case number 59, as you see, the case that has been entered in the first quarter is 888, right? Apart from this cell, all other observations are only in the 2 digits of the thousand. So obviously this numbers appears to be different from all others. These type of observations are known as outliers or extreme values, right? And these outlier or extreme value has some impact upon the data. So how can we know whether our data has some outlier or extreme values or not? Obviously this case is small, so you can manually observe whether observations are appropriate or not. But suppose the case is big, the data set is quite big, so we cannot do this by manual observation. So there should be some method to know whether data is of good quality or not. Because if data is not of a good quality, then obviously all the analysis, whatever the tool is, how good the tool is, that may not be worthwhile. So we will check whether data is of good quality or not, number one. If data is of good quality or not, the second aspect is we go for what are the basic characteristics of the data, that is known as exploratory data analysis. So for that purpose, we use the command button analyze. All the Spss tools are there in the analyze part. Means whatever the tool you want to use for analysis will comes under analyze. So this is the analyze part, right? And in analyze, since we want to describe the data, that is exploratory descriptive analysis, so we will go to descriptive statistics. Descriptive statistics means statistics used to describe the data. In descriptive statistics, we have three things. Number one, frequencies. Number two, descriptive. Number three, explore. Here, this descriptive is the most elementary one. The second is frequency. Frequency is somewhat more detailed, and explore are the complete detail. So basically, we should use explore, but just in order to get you familiarized, I will explain these two also. So we will press descriptive. So our path will be analyzed descriptive statistics to descriptive, right? Suppose we want the descriptive statistics of two quarters, quarter one sales and quarter two sales, right? This is just for the demonstration purpose. You can enter one by one, and you can enter all four. Suppose we are considering only two. So these are the two sales, and for these two sales figure, quarter one sale and quarter two sale, we want to analyze, we want to know the descriptive statistics. So what are the descriptive statistics that are available under this heading? This is available from the options. Some default options are there. Mean has already been ticked. Standard deviation is there. Maximum and minimum is also there. Suppose you want something else. Suppose you want range. Suppose you want skewness. So you can increase the options through clicking or checking the appropriate boxes. And this is known as sub dialog box, because from this dialog box we move to this sub dialogs box, and in order to go from sub dialogs box to the main dialog box, we will press continue. So now everything has been entered and we will press OK. Okay, so this is the output that is visible to you, right? So now if we observe this output, this is the output that is there. So this, as we observe this output, as we see, number one, in the first column we have n. N is the number of observations. Here we have two type of information. One is, as you see, we have a sample of 60, right? But here 60 and 60 are written, and there is one more um, entry, that is a valid n list wise. It means the actual sample sizes are 60 and these are the valid observation. Valid observation means non-missing observation. If suppose 4 observations are missing, in case 4 observations are missing, so in that manner the valid n will be 60 minus 4, it will be 56, right? So these both the variable have 60 observations, right? Now, since we have to comment on the average sale, so we will use the mean. Means the arithmetic mean. As you see, the first quarter is having a mean of 85 and second quarter is having a mean of 72. So just by observation, we will have an impression that company is doing very good in the first quarter, giving a sale of 85, and the company is not doing so good in the second quarter, that is 72. But this may be defaulty also, right? Because it might be possible that some extreme values or some extreme observations may have impact. So now we will perform some better analysis. Again we go to this SPSS file and we go to analyze, then go to descriptive statistics, and now we move to somewhat more comprehensive part, that is the frequencies. So this is the frequencies. This is the dialog box of frequency. Again we use two variables, first quarter 1 sale and quarter 2 sale, and these two have been entered. Now we have statistics. As you know, here different type of center tendencies are there. So one is mean, other is median, next one is mode. So as some of you know, that mean is calculated by summing up all the observation and dividing by number of observation, so it get affected from all the observation. And median is simply the middle observation if the entire data is arranged in some order. So if data is of normal type, data is of appropriate type, then obviously mean is the best measure for the central tendency in order to define its general tendency. But if data is having outlier or extreme values, then obviously median is better. So earlier in the descriptive part, we don't have the option for median, but here we have option for mean and median both. So we can have mean and median both. Suppose our data is non-metric in nature, non-metric means categorical in nature, then we have mode option. But mode is not useful in here. And in the same manner, we can press standard deviation, we can press range, and we can press skewness also. So these are the some statistics that has been used. The second option, that is the visualization part, that is the chart option. If we press chart, then we have different options. So we can press a histogram, and suppose we want to check whether the data is normal or not, we can also have show normal curve on the histogram, and we press continue, and then we press OK. Now, this is the second output that has been derived using the option uh, frequencies. Right? We will concentrate upon this part of the table. Here you see in both the variables we have 60-60 observation, and the volume of missing observation is 0-0. Why the missing observation is given? If missing observations are too high, means the percentage of missing observation is much high. So obviously if missing observation are high, then it will have an impact upon the quality of the data. So we have to do some missing value treatment. Missing value treatment means if a large number of missing values are there, we can replace those missing values using series mean or median. Now, we compare mean and median. For the first quarter, mean is 85, and for the second quarter, for the first quarter, median is 70. For the second quarter, mean is 72 and median is 73. If we compare the values of mean and median, so here we observe a large difference, but in the second quarter, difference is not so large, right? So what does this signifies? Since outlier or extreme values have an impact of mean, if outliers are of higher side, then mean will increase tremendously, and if outliers are on the lower side, then mean will decrease by a sufficient amount, right? But outliers either on the higher side or on the lower side has no impact upon the median. So if there is substantial difference mean and median, so it signifies that some outliers are there. And if there is no sufficient difference between mean and median, means outliers are not there. So here when we compare, we see that there is a substantial difference mean and median. So it indicates that there may be outlier in the first quarter. And here there is not much difference, so it means outliers are not there. This can be checked by following the graph. When we see the first quarter histogram, right, as you see the first quarter histogram, here as you see there is a large gap between these observations and the next observation. There is a large gap, as you see, means there is no observation starting from this point to this point. It means outliers are there. While in the second quarter, as you see, there is a normal curve. There is a gap, but this gap is not so substantial. So it means the first quarter is having an outlier and the second quarter is not having outlier. So obviously this thing cannot be figured out if we consider the earlier two, that is the descriptive. This is about frequencies, right? So just to get you familiarized with the output, and now we will go for the most detailed case, that is explore. Means we can directly use the explore option. So we will use explore. Again we will use two quarters, quarter 1 cell and quarter 2 cells. So one thing is this pan is known as input pan. All the variables present in the data sheet will be there in the input pan. We can transfer the appropriate variables into the right pan, which are meant for the analysis. So we have taken quarter 1 cell and quarter 2 cell, and these are entered into the dependent list. Right? Dependence list is which variable is to be used for the analysis purpose. There is one more option in here also, that is the factor list. What is the role of the factor list? Suppose you want to obtain the descriptive as you see all the descriptive statistics that we have obtained are for the full sample of 60 cases, means all type of outlets, all type of executives are there. Suppose you want the sales of quarter one and quarter two sale separately for the urban outlet and for the rural outlet, right? So in that case we will enter type of outlet in the factor list. So the entire output will be divided into two parts that I will explain later on. So now we are not using the factor list. So here again we are using quarter one sale and quarter two sale, and we will press statistics. So as you see in this sub dialog box, descriptive has been ticked, and there is one more option, that is M estimators. The role of M estimator is just like measure of central tendency, means just like mean, median and more. But these M estimators are known as robust estimator. What do we mean by robust estimator? As you know, the word robust means there won't be much impact of the circumstances on that person. That person is known as robust. In the same manner, M estimators are the robust estimators, and they are not much affected by extreme values. So if data contain extreme values, then there won't be any impact upon the M estimator. So we have checked M estimator. Since we also want to know whether our data is containing outliers or not, we want to see where the outliers are present. So we have checked outliers also. Then we press continue. So this is related to statistics. And then we press plots. As you see, we have different type of plots. Box plot is there, stem and leaf is there, right? Probably you are not much familiar with the stem and leaf. You are familiar with histogram. So हम लोग ने इसमें कर लिया. We have checked histogram also. And we also check normality plots. The objective of the normality plots is to find whether data is following normal distribution or not. Why this is important? Because we have two type of tools, two type of tests. Some are parametric test and some are non-parametric test. The condition is if data is following normal distribution, we will use parametric test, and if data is not following normal distribution, we will have non-parametric test. Then we press continue, and then we press OK. So this is the output. So in this output, the first output represents the case processing summary. This is quarter one sale having no missing observation, right? And then we have descriptive statistics. Up here in the descriptive, just like earlier output, in the first quarter we have mean as 85 and median as 70. There is a large difference between mean and median. It signifies that some outliers will be there. There is one more option. As you see, this option is 5% trimmed mean. 5% trimmed means trimming has always been done on the extreme side. So 5% trimmed mean means 5% lower observation and 5% upper observation has been trimmed. Means 5% trimmed means data will consist of 90% part, and this 90% part will be in the middle only. Means 5% upper values have been trimmed and 5% lower values have been trimmed. So obviously if data contain outliers, then by trimming outliers will be eliminated, right? And if data does not contain outliers, then obviously there won't be any impact. So as you observe the first quarter sales, here the mean is 85, 5% trimmed mean is 71. Again, there is a major difference between 85 and 71. But when we observe the second quarter, in the second quarter, mean is 72.43 and 5% trimmed mean is 72.48. There is not much difference. So why in the second quarter there is not much difference, and why there is much difference in the first quarter? Reason being, the first quarter has an outlier. So outlier will have impact upon mean, but outlier won't have any impact upon 5% trimmed mean. Since by trimming outlier has been eliminated, so there happens to be a major difference between mean and 5% trimmed mean. So here there is major difference, and here the difference is quite negligible. So right, and further we see the median comes, there is a much difference between mean and 5 and median, right? And there is not much difference between mean and median in the second quarter. So what does this signify? That quarter one is having outliers. So in case our data is having outliers, so we don't report mean. We can report 5% trimmed mean, or we can report median, because they represent the better measure. But if data does not contain outliers, then obviously mean is the better measure. These things have been get confirmed using M estimators. M estimators are least affected by extreme values. As you see in the first quarter, all the M estimators are around 71 point something or around 72. And when you see the first quarter data, 5% mean and median, they are much closer to 72. Right? And in the second quarter, as you see, mean is 72, 5% trimmed mean is also 72, median is 73. So there is not much impact of the outliers on the M estimator. So in order to suppose we want to report the what is the average sale of the first quarter, so instead of 85, the better figure that should be reported is around 72. And in the second quarter, since outliers are not there, so it doesn't matter, you can report mean or 5% trimmed mean or M estimator. Further, so we have observed that outliers are there. So using this outliers option, we can find out where are these outliers are situated. As you see here, in the first quarter, the highest value is 888. The next values are 90, 88, 87, 86. So there is much difference between 90 and 888, right? But in the second quarter, among toward the higher side, we have 92, 90, 89, 86, 86. There is not much difference between 92 and other values. So it simply shows that outliers are there in the first quarter. And this outlier 888 is situated at case number 59, right? Now outliers may be present on the lower side also. So on the lower side, these values are 54, 57, 57, 58, 58. There are not much difference, right? So in that manner, we can check whether the outlier is on the higher side or towards the lower side. So what does this signify? It signifies that it is giving us instruction that there should be some correction that are to be made for this value, means this value 8888. So how these corrections can be made? We go to the data sheet and we see what case number 59 shows. So here we have 888. So one method is these outliers or the extreme values are bad values, so they may be eliminated. One thing. And the second thing is, suppose you don't want to eliminate, you can check whether this data is a wrong entry or data is a correct entry. So actually what has happened, the actual values are 88 only. So actual values are 88, but wrongly it has been pressed as 888. So we can make corrections in 888. So now we have improved the data, right? Okay. So now we will discuss the other part. Now the other part is related to whether our data is following normal distribution or not. There are number of tools to decide whether data is having normal distribution or not, right? So first is testing normality. As you see, Here we have two tests of normality. One is Kolmogorov-Smirnov and other is Shapiro-Wills. Here, in both the cases, we have the hypothesis S naught as our data is normal, and this is the p-value. Significance is the p-value. So when you observe the p-values, so in the first quarter, the p-value is 0.000. This 0.000 is less than 0.05, means S naught is rejected. H naught is rejected means this data is not following normal distribution. So it happens just because of one observation. And in the second part, in the second quarter, we have p value as 0.200. 0.200 is 20%. 20% means H naught is not rejected, H naught is accepted. So we can say that we can say that this is following normal distribution, right? So this shows a single observation has impact upon the normality of the data. This normality can further be checked using normality plots. This is very much useful in the when we perform regression analysis. So first we consider the normality plots for the second quarter, right? Here the normality plots is plotted in between two values. On the x-axis we have observed values, and in the y-axis we have expected normal. So suppose our data is normal in nature, then obviously expected values and the observed value both will be same. Since I am explaining it again, this normal QQ plot or normality plots has been plotted with observed values of the data on the x-axis and expected value, expecting that data is following normal distribution on the y-axis. So if data is normal in nature, then observed values and expected values both will be same. So since both will be same, so they will lie on the 45-degree line. So on the 45-degree line, both x-axis and y-axis both will be same. So if data has majorly been plotted on the 45-degree line, right, then that may be considered following normal distribution. As you see here in the second quarter, data is mostly plotted on the 45-degree line. So we can say data is following normal distribution. But if we go to the first quarter data, so this is the first quarter data. This is a normal QQ plot for the first quarter. So as you see here, the data is much deviated from the 45-degree line. It shows data is not following normal distribution, right? So this is about the normality plot, and this can also be checked using box plot. This diagram is known as box plot. It starts, this is the minimum value, this is the first quarter, means 25% of observation. This is the median means 50% of observation. This is the third quarter, means 75% of observation, and this is the maximum value. If data is normal, then these two boxes are of equal size, and these two whiskers, muche jo hain, these two whiskers are also of the approximately equal size. So as you see here, two boxes are of equal size, and two boxes are of equal size with each other, and two whiskers are also approximately equal. So we can say that missing values, that they are following the normal distribution. There is a question how to remove missing value in the rows of SPSS, right? I am explaining it. Right. Suppose here in the first quarter, these values are missing, right? These values are missing. So just for the example, suppose in a class, you know that the average age of the class is 17 years. Suppose a new student arrives in the class and you don't know what his or her age is, but we can easily presume that his or her age is also around 17. So what we do, if we don't have information or the values are missing, then we can replace these values using series mean, right? So we can replace these missing values using series mean. So how this can be done? We will go to transform. In that transform drop down, we have an option of replace missing value. When we replace missing value, so this is the dialog box. Suppose the values are missing in the first quarter. So we will enter the variable as Q1 sale, and we can replace the missing values using series mean. There are some more option. One is mean of nearby points, median of nearby points, linear interpolation, linear trend. The most common option used is series mean. Mean of nearby points will be used. Suppose you are collecting data from different geographical regions or different part of the demography. So in that manner, you will use mean or median of nearby point. Suppose you are using some financial data. So in that case, we will use linear trend or linear interpolation. So by this manner, we can remove missing values in the rows of SPSS, right? So this was the question that I have been answered. Any other question, or should we move forward? Any other question?
सर सर
Yes.
क्वेश्चन आंसर लास्ट में होगा, लास्ट में सबसे क्वेश्चन पूछ लिया जाएगा.
Okay, okay. चलिए. Right. So by this manner, we have changed the data, right? Suppose we want to check what is the impact of changing these values. Again, we will go to analyze, and then we go to descriptive statistics and go to explore. Now here I am using only for the first quarter because we have make changes in the first quarter only. So we have the first quarter values only, and we press OK. Right. As you see, after correcting that value 888, that was a bad value. Now the mean comes out to be 72, which was earlier suggested by M estimators and etc. Here the 5% trimmed mean is 71, median is 70. Right? Here you observe that these values are around 72, and here the highest value is 90. Test of normality, here the p-value, earlier the p-value was 0.000, now the p-value is 0.05. So 0.05 means H0 won't be rejected and it will be accepted. And when you see the normal probability plots, right, as you see here, the most of the observations lie on the 45-degree line. So now you can have the fair idea how the single observation destroys the characteristics, entire characteristics of the data. Here also, when we consider the box plot, here the two boxes has become approximately equal and two whiskers are also approximately equal with each other. So in that manner, only single observation change has changed many things, right? So hope it is clear how what do we mean by the quality of data and why the quality of data is very important. And normally in the research papers, it is also expected that you should have some comment upon the quality of data. Quality of data means what you have done to remove the missing observations or data is containing outliers or not. Right? Hope this is clear to all. Right. There is one more thing that I have mentioned, that is using the factor list, right? Suppose we want sales of outlet in the first quarter subdivided into rural and outlet uh, type. So as long as so far we are having outlet for the complete data set for the complete sample. Suppose we want to divide into two parts. One is related to outlet number 1, that is the urban, and the outlet 2, this is the rural. So we have entered the type of outlet in the factor list, and we press OK. Right? As you see here, the entire output has been subdivided into two parts. There have been 37 urban outlets, 23 rural outlets. Urban outlets are having average sale of 67 and rural outlets are having average sale of 78. Right? The entire output has been subdivided into two parts. Test of normality for the urban outlet and test of normality for the rural outlets. Right? So the entire output has been subdivided into two parts. Right? So by this manner, we can subdivide our output or our data into different parts. Okay. Now, now we will start with the parametric or non-parametric testing. Right? So parametric and for parametric and non-parametric testing means which type of tests are to be applied. If our data is following, I am repeating again, if our data is following normal distribution, then we will go for parametric tests like T test, F test, etc. If our data is not following the normal distribution, we should go for the non-parametric test. So just get you familiarized with this type of test. We have T test, F test in the compare mean part. Here we have these type of tests, and here we have non-parametric tests. These are the non-parametric tests. Mann-Whitney test, two independent sample test, Ruskell-Wallis test, k independent sample test, Wilcoxon test, or two related samples. These are the non-parametric tests. So if our data is following normal distribution, we will use compare mean option. If our data is not following normal distribution, then we will use the non-parametric option. So the most useful test to examine whether our data is following normal distribution or not is Kolmogorov-Smirnov test. So Kolmogorov-Smirnov test can be used to find out whether our data is following normal distribution or not. There is a question: which multivariate statistics should be used to analyze the effect of 5 independent variables on a single dependent variable? So this is the case of regression analysis, right? In the regression analysis, we consider the relationship between a number of independent variables and a single dependent variable, right? So Dr. Sudhir Kumar, this is the answer of your question. Okay. So now, so first we check whether our data is following normal distribution or not. So the best method is using Kolmogorov-Smirnov test. So Kolmogorov-Smirnov test was very much there in the explore part that I have shown. Kolmogorov-Smirnov part by nature is a non-parametric test, so this is also available in the non-parametric test part. So how this can be retrieved directly? We will go to non-parametric test, then we go to legacy dialog, then we go to one sample case test. One sample case test means one sample Kolmogorov-Smirnov test. So we will press one sample Kolmogorov-Smirnov test. So this test is used to test whether our data is following normal distribution or not. We can also check whether our data is following uniform distribution. We can also check whether our data is following some other distribution like Poisson or exponential. But here the most useful test is the normal test. Suppose we want to check whether these 4 quarters are following normal distribution or not. So we enter these 4 quarters sales into the output window, right? And we will test whether our distribution is following normal distribution or not. And we will apply Kolmogorov-Smirnov test. And we press OK. This is the output of Kolmogorov-Smirnov test. Here H0 is test distribution is normal. So H0 is our data is following normal distribution. As you know, all the software use p-values to decide whether to reject the hypothesis or not to reject or to accept the hypothesis. And here the p-values are asymptotic significance. These are the symbols for the p-values. So the first p-value for the first quarter is 0.415, for the second quarter is 0.746, for the third quarter is 0.656, and for the fourth quarter is 0.567. So we compare these p-values with our level of significance, that is the 5% value. If these values are greater than 0.05, we will accept the hypothesis that distribution is normal. If they are less than 0.05, we will reject the hypothesis that distribution is not following normal distribution. As you observe, all these p-values, all these asymptotic significance are greater than 0.05, means all the data, means quarter 1 cell, quarter 2 cell, quarter 3 cell, and quarter 4 cells are following normal distribution, right? So they are the following normal distribution. So since they are following normal distribution, so we can employ parametric test to this data set. And if they are not following normal distribution, then we have to use equivalent non-parametric test in order to examine uh, uh, the analysis. Right? So now we will have some parametric tests. Now, as in the research, we always have some demographic characteristics. In all the demographic characteristics, we compare values with respect to, suppose we want to compare values with respect to gender, means whatever your variable of interest is, whether the two genders, male and females, are showing equal response to that variable, or they are having different response to that variable. Means we want to compare their mean with respect to the gender, right? So we want to compare whether their means are same or not, right? So here we are using primarily two samples, one from male and other from females, and these two samples are independent of each other, since any respondent that belongs to the male sample will not belongs to the female sample. So these two samples are independent in nature. Since they are independent in nature and we want to compare these two, so we have to employ two independent sample t-tests. Here in this data we can also employ two independent sample t-tests. Suppose we want to compare whether the sales of rural outlets and sales of the urban outlets are same or not, or there is substantial difference, right? So we will go to analyze, and since our data is following normal distribution, so we will go to parametric test. We will go to compare mean. In the compare mean part, we have two tests. One is independent sample t-test and other is paired sample t-test. So first we will cover the independent sample t-test. Independent sample test means two samples are independent. Just like in this case, one sample consists of male, subsample consists of male, and other subsample consists of females, right? So we want to compare whether their average sales are same or not. Suppose we want to compare it for the first quarter. So this is our test variable, that is the first quarter, and the grouping variable. Groups are created using type of outlet. Type of outlet means they differentiate between urban outlets and the rural outlets. Again, I have just repeating that. Here the test variable is, we want to compare sales of the first quarter only, so we have using sale of first outlet in the first quarter in the test variable part, and the grouping variable. Grouping variables means the variables that create groups. They are entered in the grouping variable part. Now, as we entered the grouping variable, they ask us to define the type, means what we want to compare. If the type is one. Here the type is group 1 is 1 and group 2 is 2. Since t test, z test all are symmetrical tests, so it doesn't matter whether you take group 1 as 2 or group 2 as 2, or group 1 as 2 or group 1 is 1. because both are symmetrical, curve is symmetrical, t-test curve, t curve and the z curve both are symmetrical, so it doesn't matter which one is taken as a group 1 or which one is taken as group 2. And then we press continue, and after that we press OK. So this is the output. Now as we observe, the average sale of the urban outlet is 67 and the rural average sale of rural outlets is 78. There is a difference. There will always be a difference. But this difference is actually in the sample only. So we are not sure whether this sample will be significant or not. Means this difference, which this difference is visible in the sample, this difference will be there in the population. If this difference is there in the population, means this is a significant difference, and there might be chances that there is a difference in the sample, but this difference won't be there in the population, so that is known as insignificant difference, right? So this table is not of much use to us in the present case. So first we check whether our data, whether this difference is significant or not. Again we use the p-value. So this is our test, independent sample t-test. This is the output of this test. Here we observe that p-values are less than 0.05. The p-value is 0.000. This p-value is less than 0.05, so we will reject H0. We will reject H0 means we will reject the equality of the mean. Since mean are not equal, then only this table comes into the picture. And when there is happens to be a significant difference in the mean, then we see that these values are significantly different, then only we can say that rural outlets are giving higher sale as compared to urban outlets, right? So this is related to uh, applying t-test. Means this, there will be a difference, but this difference may be significant or not. I am repeating this analysis once again. Suppose we want to compare sales of the outlet of eastern outlet and the western outlet, right? Now we want to compare the sales of eastern outlet and the western outlet. Again there are two groups only, so we will go to compare mean and then we go to independent sample case, right? We repeat this analysis. Now suppose we are taking sales of the outlet of the third quarter. So third quarter has been taken just for the demonstration purpose, and groups are created using location. Here we want to compare sales of the second quarter with the sales of the second group. Second group means the eastern group, with the third group. Third location is the western group. We want to compare eastern and western group, and we press continue, and then we press OK. Right. Now here you observe what the variable is sales of the outlet in the third quarter, and we are comparing our outlet sales with respect to eastern and western regions. The eastern regions are giving average sale of 62 and western regions are giving average sale of 60. There is difference, but we will check whether this difference is significant or not. For that purpose we will go to the main output, that is the independent sample test output. So when we go to independent sample test output, here we observe the p-values. P-values are 0.464 and 0.473. These values are greater than 0.05, means they are not less than 0.05. So we won't reject the null hypothesis of equality of mean. Means we say that means are not significantly different. So we can say there is not substantial difference between eastern regions and western region. Means this difference 62 and 60 becomes meaningless, or this difference is insignificant, right? So this is the role of t-test. Okay, so hope these tests are clear. Now we are moving to another test, another type of t-test. Okay, As you must have read in the case, uh, there is an advertisement scheme that is employed uh, in the end of the first quarter. So we want to know whether there is significant difference between quarter one sale and quarter two sale. If quarter two sale has been significantly enhanced as compared to quarter one sale, then we can say that advertisement are having some immediate impact, or otherwise we will say that advertisement are not having an immediate impact. So we want to compare whether Q1 sale and Q2 sale are same or different. How it can be useful for a research paper? As you know, with the Professor Banerjee getting the Nobel Prize in economics, there is suddenly much emphasis upon randomized plots. Means research papers are very much accepting the papers that are using randomized plot or the experimental design, right? So in the objective of the experimental design is to perform some treatment and to observe whether that treatment is having some impact upon the performance or the response of the respondent or not. So this is a much popular case in this case. So in the same manner, suppose you want to see whether there is some impact of some intervention or not, right? Suppose you are giving students some remedial classes and you want to check whether remedial classes are having a success or not. So obviously we want to compare their pre-remedial classes performance with their post-remedial classes performance, right? So here also the case is just like that. Here the intervention is advertisement and we want to compare the sales of first quarter and the second quarter. So obviously when we compare the outlets for the advertisement impact, then it is logical that only first quarter and the second quarter, first uh, outlet should be compared with the first outlet only. The same manner, if we want to compare fifth outlet, then obviously fifth outlet should be compared with the fifth outlet only, right? Means we will have observation on the same outlet, one in the first quarter and one in the second quarter. Means this 67 should be compared with 77, this 58 should be compared with 67 only, right? So these type of test means there are actually two samples, but these two samples are not independent. You cannot compare anything with anything, right? You have to compare only the similar type of cases, right? So these type of tests are known as paired t-test or dependent sample case, right? Because here we have two observation, one pre, one post. So these type of tests are known as paired t-test. And since the distribution is following normal distribution, so we will use compare mean. And in the compare mean, now we will have dependent sample test or paired t-test. So this is the paired t-test. The path will remain the same. We will go to analyze, then we go to compare mean, and then we go to paired sample t-test. So this is a dialog box for the paired t-test. Now suppose we want to compare first quarter and second quarter sale. And so this is the paired comparison, first quarter sale with the second quarter sale, and we press OK. So this is the paired t-test. In the first quarter, average sale is 72. In the second quarter, average sale is 72.43. There is difference. We just want to know whether this difference is significant or this difference is insignificant. So for that purpose also, we will go to the main output, that is the paired sample test output. When you go to paired sample test output and you check the p-value, here the p-value is 0.688. This p-value is greater than 0.05, so we won't reject the null hypothesis of equality of mean. So we will accept the null hypothesis that means are same. Since means are same, so we can say that there is insignificant difference between quarter one sale and quarter two sale. Since there is insignificant difference, means advertisement is not having an immediate impact. So this is the example of paired t-test. Just for the clarity purpose, I am repeating this test again. to compare the sales between third quarter and the fourth quarter, because in the case it was written that a promotional scheme has been employed in the end of the third quarter to enhance the sale. So we want to check whether the sales promotion scheme is having an impact on sales or not. So I am just repeating this test, this paired sample t-test. I am just repeating the test for Q3 and Q4. So this is the paired sample t-test. We reset the data. And now we enter Q3 and Q4. We enter Q3 and Q4. Now we are comparing the sales of third quarter with the fourth quarter, and we will press OK. Okay. Now if we observe, if we consider the descriptive table, the average sale of the third quarter is 62, the average sale of the fourth quarter is 74. So there is difference. We will just check whether this difference is significant or not. So for that purpose, we go to paired sample test uh, output. And when we observe the p-value, this p-value is 0.000, this p-value is less than 0.05. So we will reject the null hypothesis of equality of means since they are not equal. So they are not equal, so we can observe these values. Now this table has become important. This table has become substantial. And here we observe that the third quarter average sale is 62 and fourth quarter average sale is 74. So obviously there is significant difference as evident from the output, and this sales has been increased. Right? Okay. So this is about t-test, pair t-test. There is again I am taking some question. There is question from Hirel. How do a correlation between ordinal and scale variable in SPSS? Now here, as you know, the Carl Pearson correlation coefficient can be used only in the situation when we have both the variables are metric in nature, means both the variables are either scale or on the um, ratio scale, right? But if a variable is non-metric, that is ordinal, and the other variable is scale, we cannot employ the Carl Pearson correlation coefficient. So for that we should use non-parametric correlation. So in non-parametric correlation, it is there in when you go to the chi-square part, that is the cross-tab part. So when you go to the cross-tab part, there is an option of using uh, correlation between a ordinal variable and a scale variable. Right. Any other question? Just for the demonstration purpose, I am also showing the answer to this question. We will go to analyze, then go to descriptive, and then go to cross-tab. This is the here we want to attempt correlation between a metric variable and a non-metric variable. Means correlation between an ordinal variable and our scale variable. We go to cross-tab. Right. Suppose here we have two variables. One is location of the outlet, other is sales. And we go to statistics. Here you see we have an option of correlation. Right? We can press correlation, and accordingly we have entered the ordinal option. Right? So by this manner we can have this case. Any other question? Okay. Now we have around 10 minutes more, so I am taking up one more test, that is the analysis of variance or the ANOVA. Now the next situation is, suppose we want to compare uh, first quarter sale vis-a-vis location. As you know, there have been 4 locations. Just to show you, we have 4 locations. Means some outlets are belonging to northern region, some belongs to eastern, some belongs to western, some belongs to southern. Now we want to compare the average sale among these 4 regions. We have so far discussed the t-test. T-test is applicable only when we have 2 samples or 1 sample, but they are not applicable, they are not efficient if we are using more than 2 samples. So if we have more than 2 samples, just like in this case, we have to use analysis of variance. So this is another test, one-way ANOVA. Why we are taking up one-way ANOVA? Because we want to cover, we have only one variable. Only one variable is first quarter sale, and we want to compare first quarter sale with respect to one criteria only, and that the one criteria is geographical regions only, means northern, eastern, western, and southern. So this is known as one-way ANOVA. If we increase the criteria, suppose we want to compare not only with respect to geographical region but also along with the some other grouping variable, other group, that is the type of the data. So here, that in that manner we have 2 criteria, one is location, other is type. So in that case we will use two-way ANOVA. So here we are using one-way ANOVA because here data is to be divided with respect to locations only, right? So again, just I want to remind that this test is applicable when we have more than 2 groups. So we will have more than 2 groups, right? And here we will have the hypothesis: average sale of northern equals to average sale of eastern equals to average sale of southern equals to average sale of western, right? Suppose we want to compare sales of the first quarter. So we will have sales of the first quarter, and we want to compare it with respect to location of the output. So location is entered into the factor list, right? Okay, just to repeat, our variable of interest should be entered in the dependent list, and the factor with respect to groups are created will be entered into the factor list. So these are the data entry. Now here is an option, that is the post hoc information. The post hoc will be used when we reject the null hypothesis. In the earlier test, in either independent sample t-test or paired t-test, we have only 2 groups. So either they will be equal or they will be unequal. Unequal means one may be greater than other or one will be less than other. But here we have more than 2 groups. More than 2 groups means northern, eastern, western, and southern. So if H0 is accepted, then it means all groups are having equal sales. But if H0 is rejected, we don't know whether all are unequal or some are equal to one another and only one or two are different. So when we consider the ANOVA, so we have H1 not as unequal, means we will have H1 as at least one is not equal. At least one is means if we have 4 regions, northern, eastern, western, and southern, so it might be possible that 3 are same, northern, eastern, and western are same, southern may be different. It might be possible that northern and eastern are same, western and southern are same, and they are not same with respect to each other. And it is also possible that all 4 regions are different. So we can say that there are a number of H1 or alternative hypotheses in this case. So that's why we will use the H1 as at least one is different. Since we use this type of H1, so we want to know which cases or which pairs are different. So for that purpose, we will use post hoc test. So this is the post hoc test, and we will employ the post hoc test. There are a number of post hoc tests. The most popular post hoc test is Tukey. So we will use Tukey. So obviously this will be used only if these values or H0 is rejected or these values are different. There is one more button, that is option. We can use option to define descriptive or to have graph using mean, right? There are more application also, but because of paucity of the time, we are considering only this one. And we will press OK. Right. Here you see the entire output has been divided into northern, eastern, western, and southern. Right. So for this, we will consider the ANOVA output, the ANOVA table first. Right. As you know, as all the tests have been performed using the p-value, here the p-value is 0.057. This p-value is greater than 0.05. Since this is greater than 0.05, so we can say that we cannot reject the null hypothesis, or H naught is accepted. Since H naught is accepted means the difference that is evident in the sample means are insignificant, means there is not substantial, there is not significant difference between northern, eastern, western, and southern regions here. So we cannot reject the null hypothesis, we will accept the null hypothesis. Obviously, if we accept the null hypothesis, then only we will move to post hoc test. In the post hoc test, we will perform multiple comparison. Multiple comparison means only two pairs are compared, means just like now the first pair that is compared is northern with eastern. When we compare northern and eastern, here the p-value is 0.642. This p-value is greater than 0.05, so we can say the H naught involving northern and eastern has been accepted. So there is insignificant difference between northern and eastern, right? And suppose a particular value is less than 0.05, then we can say these two values are different. So second pair that is compared is with northern and western. So when we compare northern and western, the p-value comes out to be 0.416. This 0.416 is again 0.05. So we can say there is insignificant difference. So lastly, northern compared with southern. So here the p-value is 0.547. This is again greater than 0.05. So there is insignificant difference. In that manner, all pairs are compared with each other to find out what are the significant pairs that are there. So this is related to ANOVA. Now around 3:30 is there. So I just want to take up the questions. Any question?
Hello. Hello.
Hello. Any question?
Thank you, sir. Very clearly explained lecture. So there is no more confusions are left. But some participants are attending on YouTube. So I invite Dr. Arvind for any other.
Okay, I may leave my phone number and email ID if someone wants to connect to me in have any doubt, right?
Dr. Arvind, please.
सर एक क्वेश्चन है
जी जी
which multivariate statistics should use to analyze the effect of 5 independent variable on a single dependent variable in SPSS.
So in that case we can use regression. How you can regression? You will go to analyze, then you go to regression, and in regression you have linear regression. So this is a linear regression, right? Here the dependent variable is entered into the dependent part. I am just showing this particular data set is we entered the dependent variable in the dependent case and all the independent variables. Suppose here we have 3 independent variables. They are entered into the independent box, right? Then we can perform the regression analysis.
एक क्वेश्चन सर पुष्पा जी ने पूछा है as SPSS is related to social science, is it applicable in research study of natural science? What are
Obviously,
the other software?
the data will always remain a data, and all tools will remain tools, right? So you can use SPSS. Even SPSS is much used uh, uh, in the medical sciences also. They use SPSS only, right?
ये पूछना चाह रहे हैं सर, what are other software for science subject?
The other softwares are R software is there, SAS is there, so number of softwares are there.
फिलहाल अभी ये क्वेश्चन थे सर. हमारे प्रतिभागियों के सवालों का जवाब देने के लिए सर बहुत बहुत धन्यवाद आपको. क्रांति मैम. प्लीज कंटिन्यू. क्रांति मैम.
सर आप सुन रहे हैं?
Yes.
Now I invite to Dr. Raghavin for formal thank you. Dr. Raghavin, sir.
Thank you, ma'am. Thank you. It's my privilege to propose a vote of thanks for this session. On behalf of organizing committee, participants, and myself, I would like to thank to Dr. Masood Siddiqui sir for a very nice and wonderful lecture. He have cleared all the things how to use SPSS in research. The last, I would like to again say thank you very much, sir.
Okay, thank you. I have
Thank you.
shared my email ID and the phone number. In case you have some issue, you can use us. This is my email ID and the phone number. Okay, thanks.
So now we can start our next session.
Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
For the next session, we have Dr. Kadir sir from the